Is the trend toward cryogenic machining freezing? Getting rid of coolants during the cutting process was presented 2 years ago at EMO as a new avenue to productivity. It would shorten process cycles, improve tool life, and reduce the impact on the environment. Yet at this year's edition of EMO, cryotech was absent from the aisles. Still, some continue to defend this promising technology.
The cryo-technology has, of course, the advantage that you can reduce the amount of heat that goes into the workpiece and into the tool, and you can also have less waste on the chips. That means no oil, cutting oil, for example, or other fluids that will stick to the chips and make it hard to recycle. We had liquid nitrogen, CO2 and oxygen, and we decided for liquid nitrogen since it is environmentally friendly and it has the highest cooling capacity.
Walter Tools developed a cryotechnology based on CO2 and oil. They showcased the process in 2013 at EMO, but this year they chose to focus on general tooling.
We started with nitrogen, where we have minus 280, 290 degrees. Here we saw that we have more disadvantages, so we changed to CO2, where we have minus 70, minus 80 degrees, which is enough for the application. And we also saw during the tests that we have to add some lubrication, some oil. So we have now a system where we have the CO2, and in addition we have a kind of oil to support this softer cutting, let me say. We saw that this technology is not for the whole metal cutting industry, it's more for a specific kind of industry, maybe for machining of titanium, difficult to cut materials, and so we decided not to bring it on an exhibition where we show the general tooling.
The technology is best suited for the processing of tough materials.
For some of the industries, like aerospace or oil and gas industry, sometimes also for industry that uses carbon fiber reinforced plastics, the advantages are that you get a longer tool life and you can increase the cutting speeds. In the automotive business, we have typically aluminum workpiece material, and we have grey cast iron, where the advantages are not as significant as they are in an automotive, in an aerospace environment, for example.
The technology also has some other limits.
It's more expensive because you need another spindle in the machine, you need the CO2, you need also some things around the machine to adjust, so it's more expensive than a normal environment, let me say. It's more in a research stage. We don't have these big applications outside. There are few machines outside, but mainly for test, to see if they can get an advantage with this technology. It's not worldwide, and it's mainly 1 or 2 machines in a company.
Starag equipped 2 machines with CO2 at its facility in Switzerland.
Well, what we saw is that with high alloyed steels especially, we could reduce the tool wear quite dramatically. So the tool life would increase about 70%, so that of course reduced dramatically the cost. We also did tests with other challenging materials like titanium or with nickel-based alloys. What we find is basically it's possible to machine that with cryogenic coolant, then of course you don't need coolant supply and so on. I think that this is an interesting technology that will help us with many material, but it will not be an alternative for all materials to get rid of coolant.